information that is to be provided, what is the size, what is the maximum packet, and all those informations they will be standardizing. This is because there are so many manufacturers will be manufacturing this devices for the 6LoWPAN that supports 6LoWPAN. Supposing if this is not standardized, then we need to rely on one such brand, right? Only one brand, because all these devices should be compatible. So in order to avoid that, if there is a standard, every manufacturer will be manufacturing according to the standard, so that there will be a compatibility, there won't be any compatibility issues between the nodes and drivers. So this is what actually I have to go for the standardization, right? And there is some header, the security and the application and data frame, all these things are standardized. What should be the header size, what should be the header structure, and what type of security has to be implemented, and what are all the data applications that can be there, right? So all these things should be available there. And they have decided that device node frame size should be 127 bytes, the IPv6 header size is 40 bytes, and UDP header size is 8 bytes, right? And this is actually a simple diagram of a physical layer of IEEE 802.15.4, right, network devices. And here you can see on the left hand side again a similar thing, right? So there are going to be so many sensors or controllers will be available, and that will be generating some small data of tens of bytes of data, right? That will be generated, and that is given to the IEEE 801.15.4, right? It's a device node frame, and which is going to have some IPv6 header structure, that is the 40 bytes, and the UDP header, it can be 8 bytes, and all the security mechanisms will be having 21 bytes, a MAC header will be having 25 bytes, and the data is going to be 33 bytes. So it is going to frame, right? So these two things actually form the physical and the data link layer, that is the bottom two layers. And once this frame is formed, then we have to fragment. Supposing if my data size is going to be, say for example, I am collecting the data from 100 street lights. So in that case, I am going to have some 100 data, something like that. So in that case, I need to fragment the data. I need to split it into parts. And this fragmented data will be given to this IPv6 link layer, right? And once again there is an MTU, that is the maximum transferable unit, right? So that is 1280 bytes in that case, right? And this fragment will be given there, and this is given to the adaptation layer of the 6LoWPAN protocol, from which the data will be going out to the next layers, like something like your transport layer, right? So this is how the data is getting transmitted from the low end to the transport layer, right? And this IPv6 IEEE 802.15.4 standard network nodes, the device node is called the MAC, that is called media access control, right? So I think the MAC address, you know what is the MAC address of your computer, which is actually the unique number that is useful to identify a computer, right? Because we can identify a computer in a network using two things. One is IP network, so the first one is the IP address, of course, which is going to vary, right? Because in the case of dynamic IP address, we have seen the IP address will be continuously varying, but each and every system will be having a unique MAC address, right? So the device node can be identified the MAC address, which is equivalent to 25 bytes, right? The size of it. And what type of security used? There is an AES, that is actually called as an advanced encryption standard, and that is actually the security algorithm. Just hold on. That is the security algorithm that has been used, and the remaining things are going to be the application data, right? And IPv6 MTU at a data link layer, right? So the data link layer, what is the size? As I already told you, that is going to be 1280 bytes of data will be there, and that will be given into so many frames of 127 bytes each. So that is actually the maximum transferable unit of that particular data link layer that can be transmitted, right? And IPv6 MTU, that is the maximum transmission unit or transferable unit, we can say. The link layer is going to be 1280 bytes, and the link layer frame fragmentation needed in order to communicate the frame size. Of course, there is some sort of fragmentation is needed here, right? And this is the frame MTU, the same thing, right? I think we can go to the next slide. So here we are going to see the TCP/IP suite. Right. Normally the TCP/IP-suite is the combination of two protocols, right? Either TCP/IP, or in some cases we can go for UDP and IP. Right. Already we have seen what is the difference between TCP and UDP. TCP stands for transfer control protocol, and UDP is user datagram protocol. And TCP/IP suite set of protocols with the layers for the internet, right? So what are the layers available? Already we have studied about some ISO 7 layers are available there, and the TCP/IP communication has 5 layers, right, which is equivalent to L1, L2, L3, L4 and L7 of your normal ISO layer. And in the OSI, that is Open System Interconnect, L5 and L6 are included, right? In suite used layers are L5 and L7, right? And each application layer L7 protocol assigned to a port, right? And again, the L7 is actually the topmost application layer, and this application is determined the port number. Already we have seen what is a port number, right? Right, we will continue with this. And this diagram actually shows the IoT TCP/IP suite of protocols for the internet, right? On the right hand side you can see there's an application layer protocols which are something like HTTPS, HTTP, MQTT, XMPP, SOAP, FTP, TFTP. So all these things are application layer protocols. Of that HTTPS, HTTP, then FTP, all these things can be used for normal internet using our computers. And we have studied about MQTT, XMPP and SOAP, which are useful for our IoT data transmission. On the left hand side you can see application layer protocols, which is equivalent to DNS, again domain name server, we have seen that. Then boot PC, boot PS, SNMP, right, DHCP, COAP and the lightweight MTM protocols. So these are all some protocols which are useful for IoT applications, right? So these are all the different application layer protocols are available there. And then the next layer is going to be either TCP or UDP. So either it's a connection oriented service or a connection less service. And then this data will be given to the next layer, which is going to be the internet layer. Again, there are two variations are there. In the case of transport layer TCP, that is the TCP connection oriented service, there will be an acknowledged data flow will be there, right? So for each and every packet transmitted, there you should be getting an acknowledgement. But on the UDP side, there is no such acknowledgement will be available here, right? And then this data is coming into the internet layer, which is going to use either IPv4, IP version 4 or version 6. And then the data is coming to the lower end, right, which is going to have your ARP or RARP data link layer, right, which is going to be either a Wi-Fi or Ethernet protocol. Now here actually we are going to see two things. One is actually called as an ARP and the second one is going to be RARP, right? So what is ARP? ARP stands for Address Resolution Protocol, and RARP stands for Reverse Address Resolution Protocol. Of course we are going to see what is them now. And then on the left hand side you can see there is an adaptation layer where the 6LoWPAN, COAP or LW, that is the lightweight MTM protocols are sitting. So this is actually the overall set of the TCP/IP suite of protocols, right, that are useful for the internet applications. And the TCP/IP suite, the same thing again we are getting it back, and what are all the possible protocols, right, that are useful in the TCP stream communication, right? So the application layer protocols and the datagram using protocols for UDP, right, user datagram protocol, that is DNS, TFTP, boot PC, boot PS, DHCP, all those things are there. And there are some security layer protocols are also there, which is TLS and DTLS, right? And what are the transport layer protocols? Here the TCP is for acknowledged data flow. So whenever data is transmitted, I will be getting the acknowledgement for it using the connection oriented protocol. And example 2 is a UDP, which is a datagram, and this is an unacknowledged. In the sense we are going to transmit the data and we won't bother whether the data has reached the destination or not. And what are the other protocols that can be used? The one is RSVP, DCCP, and there are many protocols are available in this layer, right? And of course the same thing is there, right? So it's a network layer called internet layer, then IPv4, IPv6, RPL, ICMP or ICMPv6 or IP security are the protocols available here. and the TCP/IP-suite, right, data link layer protocols. So what are the available thing here, right? So PPP, ARP, RARP, of course we have seen them, and there is going to be a MAC or other MAC protocol for Ethernet LAN or DSL or ISDN. So all these things you are going to use when you are connecting your internet to the internet service provider, right? Something like your LAN you will be using, DSL you will be using, ISDN you will be using, and the MAC number you are going to use. All these things are useful for internet connections. And what is the function of TCP at the transport layer? So this is useful for acknowledged data flow when the segment is transmitted. And the TCP protocol segment consists of the data which the transport layer receives on transfer from the application layer to the other end. Of course, this we have seen. And the TCP connection oriented feature, right? So already we have discussed, it's a connection oriented feature is there, and the connection is first established, right, using a connection establishment procedure. There is a separate procedure for this adopted, and when the first time transmitting a TCP data stack. And similarly, the connection has to be properly closed using a connection closing procedure, right, that is adopted when the last sequence completes transmission of TCP data. So the connection cannot be as such cannot be created and closed. We need a specific procedure for establishing a connection and closing the connection, right? And TCP protocol data unit, PDU, the maximum data unit 2 power 32 bytes, right, which can be transmitted or received at the layer when using a TCP stream, right? So, and the protocol data unit PDU of TCP is maximum one segment, and one segment maximum value of 2 power 32 bytes, right? And the data stack header will consisting of n words, normally n equal to 5, right, and can be extendable by options, right? Already we have seen what is going to be the header structure of TCP, already we have discussed here. And this is